give you one question of this one next week, next test, and we usually check it on the final. This is because you need this one for, in case you want to take calculus, pre-calculus, okay, all of them. So this is part of section 2. I believe it was 2.6. Yes, it's 2.6 that we talked about the other night, but we didn't check this one. In fact, this is the one that you need for future. Okay, so this is part of 2.6. We want to know what is going to be composition functions. Okay, what is composition? Composition functions. We were working on the operation with the function, so this is a very popular one. So what is composition functions? You say in everyday life, when you want to do something, okay, you may have to do it in several steps. For example, you apply for a job. Very good. You have to fill up an application first. Okay, an application first. They check your application. They may ask you for an interview. So when you get to the interview, it's a combination of two actions. Okay, applying for a job and then giving an interview. So if you put these two together, you have a composition of actions. So this is the same for the functions. Okay, you want to take an A, to get an A in this course. Very nice. But you have to go through some actions, some composition, some functions, quiz function, test function, final functions. Okay, this is the type that we are going to be interested in. Okay, so this is it, the definition. We need two functions. Okay, if two functions, if the functions, okay, the functions f and g, okay, are given. So we have two functions, f and g, we know them. Okay, then composition functions. Composition functions. Okay, we are going to have a composition functions of f and g are going to be denoted, okay, are denoted by, this is the notation. We say FOG, we compose it, or GOF. Okay, it depends, the order is important, and is defined by, and is defined by. That's how we're going to define it. You see, this is two actions. Look at this one. You see, this is the input, x. You drop it into the first function, okay? You drop it into the first function, okay? This is it. So we drop it into the first function. The first function is g, okay? You apply for a job, remember. So the result is going to be g of x. You see, that's going to be the one. So they read your application. Then the next one is an interview. So we bring the next function, okay? The next function is the f function. F will read, okay, this is going to be your interview. F would act on the f of g. You see, this is going to be the output. So two action. The first action must happen, must occur. Okay, you have to apply for a job. So this is the x. You see, you drop the x into the first function, that gives you g of x. Okay, that would be the g of x. Then the next function is coming, f of g of x. So it's a combination of two functions to get to that part. Okay, so this one, we are going to call this one inside function. You see, this g is inside function. That's what should happen first. Okay, that's inside function. And this is going to be outside function. Outside function. Okay, inside, outside, to get the final answer. This is the one that we are going to denote by FOG. FOG of X. f of g of x is equal to the f of g of x. Means g would happen first, then you apply the f. Okay, any question? You may do it the other way around. You may get the x, but you may apply the first kind function, okay? The first function you may like to apply the f first. Very good. So the output would be f of x. Okay, output would be f of x. Then you bring the second function. The second function is the g function. Then you apply the g to the f, g of f of x. Okay, so if you apply the f first, then the g next, so the operation, the direction is different. So this is g or f of x. Okay, so f or g, g or f. These are going to be the composition of two functions. You can go on forever. You can compose several functions. Okay, several functions to get the job. You see, this is it. You go to the ATM machine. The first function is usually you show your card. You insert the card. The machine would read it. When the machine reads it, ask you to proceed. You ask for the money. This is the money function. At the end, you get the money. Okay, so it's a composition of two functions. Okay, the actions. So several actions to get the final result. We call it the composition of two functions. The advantage of this type of ideas are going to be, you see these two operations, they may not be the same. So it's not like a multiplication. Okay, in the multiplication, you know that 2 times 3 and the 3 times 2 are the same, but not for the composition functions. So that's why we like this type of operations. Okay, if you continue taking courses in mathematics or in physics, mechanics, you need this type of operation, and they use it, all the time. So that would be very interesting concept. Okay, any question? The best example that if you want, okay, in everyday life, my wife is, she's a mechanical engineer. So I explain it to her. Anytime we go shopping, you see, if we go to Macy's, if we go to the Macy's, they say, oh, today there is a sale, 50% off. But there is a sign. The sign will tell you that another extra 10% would be given to you by the cashier. So why not? They give it 60% right away, because they are going to use composition function and they are not going to give you 60%. You see, this is what they do. When you go to the cashier will bring the first function. The first function is 50% function. Okay, that's a 50%. Then you are out. You see, this is going to be the next part. Then with this result, okay, you already got f of x. They are going to give you 10% of this new one. You see the 10% function, and you get your whatever it is. So the first one must happen first, then they give you 10%. If you put them together, it would be almost like 55%. But psychologically, you may think that you got 60% off, which is not. Okay, that's the trick, if you like, of this type of ideas that we're going to have. Now, how we're going to use it in college algebra or in future, especially in calculus. In college algebra, we give you the function, you compose them together. When you compose, you see your action is a little bit complicated because you go through 2 steps. In calculus, we do the other way around. If something is complicated, we break it. We break it to parts. You see, in calculus, we need these 2 parts. And I'm going to show you how we're going to use it in these two cases, okay? And there is going to be a great formula in calculus that you need to know this one, to be able to take care of it. Okay, any question? Give you an example to see how we're going to operate. Okay, it's easy operation that we are going to do. We are not going to give you complicated function. Okay, it's going to be good if you take the courses like trigonometric one, sine, cosine, tangent. But in your case, they are going to be polynomial types. Okay, we give you one, and this is how we're going to test you. Okay, we give you 2 functions and we ask you to compose it. Okay, that's it. Suppose we have two functions. Suppose f of x, you see, f of x is equal to the x squared plus 3x minus 7. That's f of x. Okay, and we have another function, g of x. G of x is equal to the 5x minus 1. And we ask you to find this. Okay, find the composition of two functions. So what do we want? We want you to find g or f of x. Okay, and give us what is going to be FOG of a negative 2. Okay, that's going to be one. Just give me 5 minutes because I have nobody in the house. I have to open the door. Okay, thank you. Now we are going to continue. Okay, just finding this composition of two functions. It's just 2 steps, the definition and then the result, solution. So we go over the g of f of x first. Okay, definition first is going to be g of f of x. Okay, we have to apply the f function first. Bring the f. What is the f function? Is x squared plus 3x minus 7. That's the first action. Now we have to bring the g function. Now we're going to g function. Look at the g function. G function is g of the input is 5 times the input minus 1. You see, x is not important. You can replace the x by z. You can replace it by t. The action is important. Okay, so action of the g function is g of the box, if you like. The input is going to be 5 times the box minus 1. So if you put this on into the box, okay, to the box. So what do you want? 5 times the box. What is in the box? In the box is x squared plus 3x minus 7 minus 1. You see, this is the way we think about it. Because this is just, x is not important, it's just the action. Okay, the input is a box, so it's going to be 5 times box minus 1. But you have to multiply the 5 times the box. It's a 5x squared, okay, plus 15x minus 35 minus 1. Combine the like terms. So g of f of x is going to be equal to 5x squared plus 15x minus 36. And we are done. Any question? So the order of the operation is important. F function first, inside function. This is going to be inside of the g, inside of the g. So whatever you have to drop it inside the g. G is g of x is 5x minus 1. So G of the input is 5 times the input minus 1. You just substitute, simplify it, and do that. Any question? So that's a G of F. How about the other way around? You say, I give you this one at one number only, because this is the way we are going to operate in future. You just stay with that number. Some people replace it by X. They find FOG of X. At the end, they replace X by negative. That's fine, but it's quite a lot to do. Okay, and sometimes it's impossible, very difficult. So stay where you are, just with the same notation. It's nice, it's much easier to operate with the numbers, okay? So you want to know what's going to be FOG of a negative 2. The formula first, G first, F of G of negative 2. That's step 1. Step 2, what is G of negative 2? Go and find it. Okay, go and find it. What is G? Remember, G is G of X, 5X minus 1. So G of box. What is it, the box? Negative 2. So stop, go, and bring G of negative 2 this time. What is G of negative 2? Go to the function G, 5X minus 1. 5X, 5 times negative 2 minus 1. So 5 times negative 2 would be negative 10. Negative 10 minus 1 would be negative 11. Okay, now continue. Equal to the F of what? G of negative 1, negative 2 is G of negative 11. Okay, G of negative 11. So G of negative 2 is negative 11. Now we want to find F of negative 11. Go to the F and substitute. Okay, when it's a number, find it first. Find it first, then go back and substitute. What is the F function? You see a function, x squared. Okay, this is it. X squared plus 3x minus 7. Substitute. So this is it. I'll write it on here. F of negative 11. Go to the F function. Is going to be negative 11 squared plus 3 times negative 11 minus 7. Okay, negative 11 squared is going to be 121. Okay, 121. This is going to be minus 33. And this is going to be minus 7. So that gives me 121. 121 minus 40. Okay, and the result would be 81. So FOG of negative 2 is equal to 81. And then you're done. Okay, so I did it in 2 different formats. The format of, you see, you have to bring the X, the general format, and the local one, we call it, just at one point. So when it's a 1 point, don't bother to find all of them. Just find the one that you have. You know, G of negative 2, find G of negative 2 first. Go to the G function, substitute, nicely get it. Okay, then you get F of negative 11, come back and do it. It's like that one that I talk about, the 50% and the 10%. You see, we apply that 50% first. We get negative 11. Now we start it over and we do the second operations. Any question? So this is going to be, you know, the version that mostly we are going to use it. Okay, of course it does. The order is very important. Okay, it's very important. They give you the order. F or G means you do the G first. Okay, you have to do G. If they switch it, you have to do the other way around. So the definition first. You see, this is F or G. Look at this one. G or F. G of F of X. Okay, inside, outside. So you have to do the inside first. You do the G first, G of negative 2. When you got it, then you come back and you continue with the other one. Any question? So that's one version of these type of problems. Now, the version that you are going to use in calculus, just in case you want to take that course, okay? In calculus, we do it the other way around. When things complicated, we want to, okay, this is calculus. When things function getting complicated, we break it into parts, if you like. And we have a great theorem over there. We call it the chain rule. It's applied to this type of problems. Okay, I just give a very mild one. So what is going to be this application? This is it. They give you one function. You see, suppose a function is given to me. We give you h of x. Okay, h of x is equal to the x cubed plus 2x, everything to the 50. You see, that's going to be what? You see, in algebra, when you want to do something about this type of operation, they say, oh, order of the operation. Order of the operation is inside parentheses first, then the exponent. It's composition of two operations. Operation of the inside and the operation of the outside. So what we would like you to do in calculus is, we would like you to find two functions. Find the functions. Okay, find the functions f and g such that this h of x is a combination of f and g, is f of g of x, or simply f of g of x. We wanted to break it into parts. Give us two functions that if you compose them together, you get this result. Okay? In order to find that, you see, G is the inside operation. F is the outside. Look at this one. Inside operation is inside parentheses. That's the inside. Outside, something to the 50. So you have two operations over here, you see, easily can be found. So this is going to be the solution. You are going to suppose the inside function is going to be g of x. Inside the parentheses, you call it g. You see, that's a g. Outside, what is the outside operation? Outside operation, just a power function, something to the 50. Something to the 50. You see? If you get a composition of these two, automatically you get the h. Because the h is a combination of inside parentheses and outside parentheses. So we have to confirm it. If this is going to be the case, then compose them together. You see, find f of g of x. What's going to be f of g of x? Bring the g first. X cubed plus 2x. Remember, drop it into the box. And drop this box into the f function. What is the f function? F the function is box to the 50. You see, the f function is box. X is not important. You call it z. Z to the 50. T to the 50. Box to the 50. You see, that's going to be the box. And this is going to be box to the 50. But what is in the box? In the box is x cubed plus 2x. X cubed plus 2x to the 50. Which is exactly the function h of x. Okay, which is h of x. So we prove that h of x is a composition of two functions. You see, this is the way we are going to use it in future if you take, calculus. Because in those courses, you see there are some operations easy to operate with these two. If you want to get the same operation for the h, you say, oh, we write it down as a composition of two functions, and then we get back. Okay, that's the kind of operation, these are going to be the one for future. This is where you are going to use composition function if you take calculus or calculus business. It doesn't matter, use both of them. Okay, so this is going to be, that's just for calculus. Okay, any question? So at this level, we want to just get to know it and be able to take care of, this type of problem for us, to be able to do it. Okay, there is another application that in your book intend to use it for the next section. We can do the next section without composition function, but this is the way they ask you to do it. So this example, you get quite a lot in your book, and you may be surprised. Then we give you the answer for your surprise. Okay, let's see what the surprise is. You see, take this function. Suppose f of x is equal to the x cubed minus 1. Okay, this is going to be f of x. and g of x. Okay, g of x is cube root of x plus 1. You see, I give you two functions. F of x equal to the x cubed minus 1. And the second function is cube root of x plus 1. We ask you to find the following. Okay, you have a couple of, several problems in your book with this idea. Find what is f or g of x and what is g or f of x. That's the question. Composition of two functions. Okay, are you ready? Let's see. What is special about this one? What is the surprise? Just get the definition, substitute. You get your result. Okay, I'll go with the f or g first. F or g of x. The definition. G is the inside function, f is the outside. f of g of x. That's a step one. A step two, bring the g. Step two, bring the g. What is the g? G is cube root of x plus 1. Put it inside the box. Drop the box into the f function. What is f function? Box cube minus 1. Okay, your f function, you see the f function is f of a box is the box cube minus 1 because the x is not important. The operation is important. So what is going to be a result? It's going to be box cube. What is in the box? Cube root of x plus 1, all cubed, minus 1. What is cube root of x plus 1 to the third? What is this one? Any suggestion?
X plus 1.
Excellent. X plus 1. But remember, you have a negative 1. These two would cancel out. That give you x. So f or g of x is equal to the x. It's like looking into the mirror. Okay, x. Okay, any question? So that is f or g of x. Okay, f or g. Let's take this one, g or f of x. Okay, so I'm going to go to the next page. Any question? Are you done with this one? And nicely substitute to get that one. Let's see if we can get it here so that we can compare them together. It can be done. Okay, so the other way around, you would like to have g or f of x. What is g of x? The definition first. G of f of x. Bring the f. G of, what is f? X cubed minus 1. Drop it into a box. Take it into the g function. What is the g function? It's cube root of a box plus 1. Okay, g is, you see your g is g of a box, is the cube root of a box plus 1. What is in the box? So it's going to be cube root of box x cubed minus 1. Okay, plus 1. These two will cancel out. That give you cube root of x cubed. You know that this is equal to the x. So g or f and f or g, both of them are equal to the x, and they are equal to each other. Okay, so officially you have g or f of x equal to the x. This type of functions would have a special property that we are going to be interested in the next sections, and we are going to explain it in a minute for you. What's the relationship and why we get these functions? Okay, to get the numbers over here. Okay, and I'm going to explain it in a minute for you. Any question? So for the composition function, these three problems so far that we talk about it. Okay, sometimes we may give you these two functions. You have it in your book. They ask you to confirm that they are equal. You see g of f of x. So what we have here is, you see, you have f of g of x. It's not always the case. Is equal to the g of f of x and equal to the x. You see, that's going to be the case that you are going to have. It's a kind of, if you, this is x, it's like looking at the mirror. Okay, it's going to be like looking into the mirror. And if you want to compare it with the numbers, if you replace x by 1, for example, then it's a kind of, in the case of multiplication, you have, okay, in the case of the multiplication, if you have the number 2, for example, you multiply by the reciprocal of the 2. 2 reciprocal of the 2 would be 1/2. So 2 times 1/2 would be 1. And the 1/2 times 2 would be 1. These are those type of operations that we're going to have, and we're going to explain it in a minute. What's going to be the action? Okay, any question? Let's take care of this one first. So we are going to just give you a couple of them to find it. We need it to be able to take care of the next section. And as I told you, we can talk about the next section without bothering about the composition function. So what is going to be the next section? You see, the next section is this type of ideas that if you have a number like 5, the reciprocal of the 5 is 1/5. Okay, 5 times 1/5 would be 1. So this is going to be operation that if you do it twice, if you like, you get back to the original one. So we call the reciprocal of the, you see, the 1/5 is the reciprocal of the 5. And when you multiply them together, you get the 1. So what we're going to do is, sometimes we call it the inverse of the 5. So what we're going to do is, we are going to define this type of operation for a function. So a function would be given to what is going to be the inverse of a function. Okay, that's the idea of the next section. There are one place in this book that you are going to use the inverse function. That's why we need it, and it's quite easy function. Okay, so I'm going to explain it. Any question? So you will see it on your quiz. Okay, 2 problems on the composition functions, and we are going to practicing, and you get this one right. Now, why we need it? We need it for this section. Again, for justification of this section. What is this section about? 2.7. We want to talk about the inverse function. Okay, it depends again what you want to do in future. How much calculus are going to be interested in? Okay, are you going to be interested in calculus 1, 2, 3, or just would like to stay with the calculus for business? Okay, this is where we are going to use this type of ideas. Okay, what's going to be inverse functions? Quite interesting concept. Inverse functions. You see, any operation in mathematics, or most of the operations, would have something that we call it inverse. When you add or subtract, you see, if I give you the number 5, you talk about the opposite of the 5. Okay, what is opposite of the 5? Any suggestion? In arithmetic, opposite of the 5 is -5. You see, opposite of the 5 is a -5. So a positive 5, if you add it to -5, the result is going to be 0. Okay, this is for addition, a kind of operation that we're going to have. In the case of the multiplication, we have reciprocal. Okay, what is the reciprocal? Reciprocal of the 5 is 1/5. If you multiply them together, you get the 1. You see, the 1 in multiplication, we call them an identity, if you like. We are going to have something similar for the inverse function, but they give you different interpretation of the inverse function, okay? What is the inverse function? Let's go back to the definition that we did. Remember, we defined the function in terms of a relation. So I'm going to give you the inverse of a relation first, okay? Then we get to the inverse of the function. It's the opposite operation, if you like. So let's recall this one, would be useful. Recall that. Recall that. A relation, remember? A relation. A relation is just a collection of, okay, a collection of order base. Of order base. Remember? Order base. That's what we did before. So suppose we have one of them, okay? Suppose, okay, suppose f equal to what? F equal to the 1 and 5, okay, 2 and 3, and the 4 and 10 is a relation, is a relation. You know that this is going to be a relation. Domain of this relation is 1 to 4, and the range of this relation is 5, 3, 10. Okay, is a relation with domain of this relation is 1, 2, 4, and the range of this relation is 5, 3, and 10. That's this function, okay, a relation. So what we're going to do, we are going to define an inverse to the relation. Inverse of the relation is the one that you switch these order pairs. Okay, if you switch the order pairs, the result is going to be called inverse of the f. Okay, so the inverse of the relation you know that the relation just a order pair is going to be x and y. So the inverse of the relation f is going to be denoted, okay, denoted by, the notation is f inverse. You see, it's not the power, it's just a name. Okay, the inverse of the relation f is denoted by f inverse and is defined by, and is defined by the collection, okay, the collection of all, okay, a collection of all the order pairs this times y comma x, not x and y. When or where, when x comma y is a member of f. This means if you switch it, you see, we go with the, remember y is a function of x. Y is a function of x, we want to switch it. So in that case, you see, so this is going to be the case. What's going to be the inverse? So the inverse is going to be, just switch. This is 1, 5, you change it to the 5, 1. Switch 3, 2. Okay, switch 10, 4. You see, that's going to be the inverse. So if the relation is given to you, the relation is the members are x and y. Okay, y, x is the input, y is the output. If you switch it, you have the inverse of the relation. Look at the domain of this one. You see the domain 5, 3, 10. The domain of the f inverse is the range of the other, because you switch everything. Okay, you switch everything. So in this case, the domain is going to be, you see, the domain is going to be simply 5, 310, okay, which is the same as the range of the R that we did. And the range in this case, what's going to be the range? The range is going to be what? It's going to be 1, 2, 4, which is the same as the domain that we did before. Okay, so this is the idea of an inverse, okay? An inverse of a relation. So if you switch the x and the y, okay, the first one, y was given in terms of the x. You switch it, we get x and the y. So the original one was a relation f. The second one is the inverse of the relation f. Okay, any question? No, that's a relation. We want the function. So what we are going to do is, you see, if you switch the x and the y, and there is no guarantee that if you have a function f, if this relation, you see this relation is a function, and if you switch it, you get a function again in this case. Okay, you get a function again. But there is a possibility that you may not get a function. Okay, you may not get a function. But if you get a function, this is called the inverse function. Okay, so in this case, this is going to be one. Note that f and f inverse are functions. Okay, are functions. So f inverse is going to be your inverse function in this case. Okay, so f inverse is going to be inverse function, but we are going to define it for you, okay, officially. So what's going to be the official definition of the inverse of a function? The function would be given to by the equation y equal to the f of x. Okay, so y is a function of x. If you can switch it, if you can solve for x, you switch the x and the y. If the result is also a function, this new result is going to be called the inverse function. Okay, inverse function. That was easy because it's just order pair. But for the function, we can use algebra in order to find that. Okay, so there is no guarantee that if you give me a function, I can find the inverse of that function. But there are conditions that we're going to impose and to get that function. Okay, so that was a motivation. So I'm going to give you a definition in terms of the abstract terms. So if a function is given to you, this is it. Function is a relation. If you switch the order pairs, is switch the x and the y. So the function is solved for y, you solve it for x. If the result is a function, you know that, one input, one output. In that case, this new one is going to be called the inverse of the original function. We call it the inverse function. So I'm going to the definition of the inverse function officially. And then there are three types, easy. You can find it. The reason that you sit in this course is you are going to study exponential function and logarithm, ln function, log function. You need the inverse function for that. Otherwise, you are not going to use it. Okay, but by itself, it's going to be nice one. Okay, that's a motivation. So what is going to be official? Because this type of definition is good if you do computer science. They use the inverse function because you have a 10 points, 5 points, 5 order pairs. You can put them together. But if I give you 100 order pairs, how are you going to find it for me? Okay, it's not possible. That's why we give you a definition of the inverse function. So that's it. Definition of the inverse function. Again, operation of the inverse, very important in mathematics, various places. We're going to use it. There you are. Suppose you have two functions. Suppose two functions. The functions. Okay, eventually it's going to be very easy. But we have to be patient. We would like to give you the concept really. Otherwise, we can give you a formula. You memorize it, that. No. You should get to know it. This concept sometimes would be so useful. Okay, suppose two functions. Suppose the functions f and g. F and g are given. Are given such that you see, if you have y equal to the f of x, this is the given part. If you solve for x, you must get x equal to the g of y. So that's going to be 1, or the other way around. Okay, suppose the function f and g are given to with this condition: y equal to the f of x if and only if x equal to the g of y. If this is going to be the case, then g is going to be called, an inverse. Okay, an inverse function, an inverse of the function f. This is the thing, is exactly the same I did with the relation for you. I switch it. You see, this is going to be y equal to the f of x. I solve for x. If I solve for x, of course I get something function in terms of the y. So the second one is the inverse of the first one. It's the same. You can say f is the inverse of the g, or the g is the inverse of f. So it is going to be, g is going to be inverse of the f, and we have a notation for it. Okay, g is going to be denoted, g is denoted by f inverse. G equal to f inverse. Okay, so if you like, you can rewrite it: y equal to the f of x if and only if x is equal to the f inverse of y. So you switch exactly the way we did it. So originally you have x comma y, now you get y comma x. Okay, if you can find the second function, in that case, there is no guarantee that you'll be able to find it all the time. Okay, so your job is to find it. Okay, we give you a function, you switch it. You see, this is y equal to f of x, as we talk about it for the relation that you did. If you can switch it, switch means if you can solve for x. If you can solve for x and you get a new function, that new function is the inverse of the original one. Okay, we denote it by f inverse. It's not the power, it's just the inverse of the function. Okay, let's give an example to explain it, of how we're going to do it. You see example, we would like you to find the inverse. Find the inverse of each function. There are only 3 possibilities, and we give all these 3. First one, f of x equal to 3x minus 2. You see, it's y is a function of x. You want to switch it. This is going to be y equal to, give us x equal to. Okay, now, the way we're going to do it, there is one method of your book that I don't usually use, but I use it because, find it for the students going to be easier to do it, because they just do the switching one that I did. Remember what I did for the relation? Remember? I switched the x and the y for you. Okay? So what I did, I replaced the y by the x. So in this one, we do the same thing. It's a 2 steps. What is going to be the step that we're going to have? Okay, this is your step, 2 steps. Solution. Okay, rewrite this one. Okay, suppose you call this one y equal to 3x minus 2. Remember the order page that we talked about it. This is your order page. You see, you have x comma 3x minus 2. That was the setup order page. Now we want to switch. We want to switch. What we're going to do is, I go with the method of your book. You are going to replace, okay? You're going to switch. Replace, okay? You are going to replace the, okay, x by y, x and the y. Okay, replace, let's say y by x or x by y. This is it. Replace x and y. If you replace x and y, what are you going to have? You have x equal to 3y minus 2. Now we switch it. Solve for y. Solve for y. What are you going to get? Isolate the y so that you have x plus 2 equal to the 3y. Okay, divide by 3. So y would be x plus 2 over 3. That's your inverse function. Okay, so you are going to call this one f inverse of x is equal to the x plus 2 over 3. That is your inverse function. This is the method of your book that I don't like it. Okay, and if you do it in calculus, I will going to be questioning you right away. Okay, so but that's fine. So what they did is they switch and the x, okay, to get these numbers. But actually, this is the one that I like. This is actually what you have to do. You see, look at this one and pick the one that you like. This is y equal to the 3x minus 2. Remember, you have to find the x. You see, that's one. Is given to you y equal to the f of x. You have to get the x for me. So solve for x. Solve for x. How are you going to solve for x? Add the 2. Y plus 2 equal to the 3x. Divide by 3. X would be y plus 2 over 3. You see? That is the g function. That is going to be your f inverse. Okay? But it's going to be f inverse of y. Okay? This is it. F inverse of y is equal to the y plus 2 over 3. But you like it, call it x, call it x now. F inverse of x is x plus 2 over 3. And you're done. You see, in algebra, you do it and nobody cares. When you are going to be in calculus, when both of them are given to you at the same time, you must use different notation for this. Okay, but we don't mind. So my suggestion is this one. That's the one that makes sense. Because a function is given to you. You want to find the inverse, you have to solve for x. Okay, how are you going to solve for x? Just, add, subtract to get the x. So I give you the y, you give me the x, so I switch it. Okay, but this is going to be, because your f inverse is going to be a function of y plus over 3. But if you want to call it x, replace the y by x. F inverse of x is x plus over 3. Okay, just pick the one that you like. I don't like the method of your book, but if you want to do it, I don't mind. So what is the method of your book? What's the difference? You see the difference is at the end, you get the function of x automatically. But my notation, I get the y, then I change it to the x value. Okay, just pick the one that you feel comfortable and we accept it. You have to do it 3 times for me. Okay, so method of your book, switch x and the y. You find the y. Because always your function is, y equal to 2. But the actual one is this one really. Solve for x. Solve for x, you get your f inverse. At the end, change the y into the x. Okay, but I don't mind whichever you want to do. Okay, but I use the second one. Okay, any question? So you give me the function, I give you the inverse. What's the inverse? I have to switch. You see, I switch it. This is y equal to, I give you x equal to. Okay, so I switch the order pairs to get the inverse function. Okay, that's type 1. Ready for the next one? 3 cases, and we give all the 3 and then be done. In I teach discrete mathematics. This is the way we do it over there for computer science. Okay, they like this type of function. What's the next case? This is the next one. The next one is the one that we did, in fact. F of x equal to x cubed, okay, minus 1, minus 2, it doesn't matter, minus 2. You want to find the inverse of this function. Okay, 2 steps, solution, I do my method. Okay, suppose, you call it y, suppose y equal to the x cubed minus 2 and solve for x. That's it. Solve for x. This is it. Y equal to the x cubed minus 2. In your book, you switch. I give you both methods. Solve for x. Solve for x means y plus 2 equal to x cubed. Okay, or x cubed is equal to the y plus 2. In order to find the x cubed, you have to take the cube root. Cube root of x cubed is the cube root of y plus 2. Cube root of x cubed is x. X equal to cube root of y plus 2. That's it. You give me f, I give you g. Okay, the definition that I have. So this is f inverse, but f inverse of y equal to the cube root of y plus 2. Why? Because f inverse is a function of y, it's not a function of x. But if you'd like to change it to the x, doesn't matter, change it to the x. F inverse of x, that gives you cube root of x plus 2. And then you're done. Any question? So far so good. Okay, the function was nice. You get the result. Okay, so I give you the y, you give me the x. If you can give me the x, I have the inverse function. Okay, so the question is, can you do it all the time? I give you a surprise. Let's see if we can do this one. Easy function, x squared. Let's see if you can give me the inverse of this function. Okay, are you ready? I give you the y, you give me x. Solution. Suppose y is equal to the x squared. And can you solve for x? Solve for x. How are you going to solve for x? You see? You have x squared equal to the y. This is right down in this format. X squared to the y. In order to solve, you know that you have to take the square root. X squared equal to the radical y. Remember, you are looking for x. What is radical x squared? Radical x squared.
X.
Let's see if you're right. Are you sure about that? Any
Absolute
others?
value of x.
That's it. Absolute value of x. You see, it's so crucial for this one. The difference between this absolute value of x, absolute value of x equal to radical y. But you are looking for x. Remember, when we have the absolute value, you can drop the absolute value, but you have to pay for it. That's it. But remember, for a function, you must get only one solution. You have two solutions here. If you get two solutions, means you cannot call it f inverse. You cannot call it a function. Okay? Remember, one input, one output. When we get the inverse function, for the inverse function, okay, you give the y to the inverse function. The result would be radical y and the negative radical y. So since you don't get any solution, you don't get the x unless you have, you have a condition over here. Okay, so you get the function of y, you get the relation. Okay, you can call this one, you can call this one what? That's why I tell you stay with the notation of the y, not the x. You see, If you want to call it, this is going to be positive negative y. You know that this is not a function. Y is not a function because I give you y. What are you going to give me? You give me a radical y and you give me a negative radical y. They share the first component. So this means f inverse is not a function. Not a function. You see, that's why I emphasize to stay with this notation rather than the notation of your book. To get these, all the numbers in your book are nice. Okay, you won't get this type of, difficulties if you like. So this is a relation, but it's not a function. It's not a function because you just having you share the first component. Remember, you cannot share the first component. So if you just only find one x, then it's a function. Look at the one that we did before. I give you cube root. You see the cube root? Because for the cube root, you don't have the absolute value. You don't need the absolute value because cubed, the fifth, the seven. But the square, you'll be in trouble. So this means y equal to the x squared has no inverse. Okay, y equal to the x squared has no inverse. Of course, on its domain. What is the domain? Domain is R. But you can restrict it. You see, if you know that x is positive, that would be safe. If x is positive, you arrive at the x equal to radical y, which is a nice, inverse function. So that's a difficulty, and the notation is very important, okay, to get these type of numbers. Any question? Just make sure that you understand what's going on. We already talked about it. Y is a function of x. What does it mean? This means I give you x, you give me only one y. When you switch the other way around, okay, I give you y, you must give me, you must give me one x if you like. But I give you the y, but you give me two, okay, two x's. So in this case, this operation is not going to go through, and then you are not going to get the inverse function. Okay, any question? So, as I told you, you are not going to get very tricky or picky about these type of problems, but this is what would happen if you take okay, if you want to be more serious about this inverse function. But the way we are going to use it is a very unique function, and you'll be fine. Okay, any question? So stay with, okay, I don't mind if you want to use that idea of your book, but stay with this notation, okay, to make sense. Y is a function of x, inverse x, give me x as a function of y. Okay, now we have another one, which is more interesting for the purposes that we're going to have. Okay, so let's check that's number 2, 3. Let's check this one. This is in your book. Okay, very popular function. So this is it. F of x equal to, okay, is equal to the x plus 1 over x minus 2. What's the domain of this function? Domain? Any suggestion?
Is it 2?
No, domain. What is 2 about 2? You know that it's a rational function. Okay, it's a rational function. You got to be careful. You make sure that the denominator is not equal to 0. Denominator would be 0 at x equal to 2. So the domain of this function would be what? Would be all real numbers except 2. Remember? So the domain of this function is what? Domain of this function is everything except 2. Negative infinity to 2 union with 2 and positive infinity. That's the domain. Okay, let's try to see if we can find the inverse of this function. As we talk about it, you call it y. Suppose, okay, suppose y is equal to x plus 1 over x minus 2. That's going to be the case. And solve for x. Okay, any suggestion? How can you solve this one for x? Any suggestion? You have to give it a fraction. Okay, to be able to solve it, you see, this is it. Y is equal to the x plus 1, okay, over x minus 2. That's x plus 1. You may think about the y as y over 1. Cross multiply. You see, cross multiply. So that give y, that's going to be x minus 2, or just y times x minus 2 is equal to the, this is it, 1 times, okay, 1 times x plus 1. Remember, you want to solve for x distributed. So that give you xy minus 2y, and that give you what? That give you x plus 1. In order to solve for x, you have to isolate all the x's on one side of the equation. So I have the x times y, subtract minus x equal to 1 plus 2y. Continue, solve for x. If you want to solve for x, you cannot combine these together. So we have to factor out the x, times y minus 1 equal to 1 plus 2y. Okay, you want to solve for x, you have to divide. Divide by what? Divide by y minus 1. Of course, you must be careful. You cannot divide it all the time. Because if you want to divide, you have to assume that, let's divide it, then you will find out. If divide by, you see, divide by y minus 1, and this is going to be 1 plus 2y, divide by y minus 1, these two would cancel out. We got the x equal to what? 1 plus 2y over y minus 1. You know that you have to impose a condition. You must make sure the denominator is not 0. So you have to tell us, oh, I assume that the y is not equal to 1. Okay? You assume that the y is, okay? The y is not going to be equal to the, okay, equal to 1, and this is going to be inverse function. So we get f inverse of y, which is equal to the 1 plus 2y over y minus 1. Okay, y minus 1. But since you love x, change the y into the x. So the inverse function is f inverse of x equal to what? 1 plus 2x over x minus 1. And we know the condition, of course. The condition is that this is part of the domain. You don't have to write it down. Okay, so f inverse of x would be 1 plus 2x over x minus 1. But you have to impose this condition to start with, okay? Just keep going. You consider, over here, of course, x is not equal to 1, because that gives you the domain of the inverse function. This is a very popular function to get the inverse of this function, okay? Must make sure you know it. We call it a bilinear function in physics. X plus 1 over x minus 2. Okay, nicely call it y. We call it y over here. We want to solve for x, cross multiply. You cross multiply it. You are looking for x, put the x's on one side. Put the x's on one side, everything is on the other side. You cannot combine together. So you have to factor out the x. We factor out the x, that gives x times y minus 1, and then you divide, you get eventually f inverse of y, which is the function. Okay, the inverse function is a function of y. But if you want to write it down as a function of x, you call it f inverse of x. F inverse of x is 1 plus 2x over x minus 1. These are 4 very popular, okay, very popular inverse function. Okay, they are going to be used quite a lot, you see, in future. As in your case, it's going to be just one case really that you are going to use it. But if you take more courses, then we have to use it for the exponential function, okay, for the log, and you will see it later on. Okay, I give you a break if you like. 10 minutes, we come back, and I check a couple of problems. There is one more condition. I try to avoid it, but I'm going to explain it for you. That condition of the composition function, and then we are done with this chapter. The next chapter is a great one, and we try it. We just get to one part next week, and we give you the quiz. Okay, this is 8:30 to 10 minutes, and we come back and we finish this one, and then we're done. Okay, that is the inverse function. Okay, we just used algebra to give you this definition of the inverse function. In the future, sometimes we can use geometry to find out whether a function is going to be invertible, if you like, has the inverse or not. Okay, just give you that one. Again, you are not going to take or to have many functions with this property, but we are going to give you this one in case you change and you go to the, as I talked about it before, college algebra and the trig functions. In the case of the trig function, you need this type of interpretations. Remember, if the graph is given to you, we talked about it before, a graph would represent the function if it satisfies the vertical line test. The vertical line test means for any vertical line would intersect the graph at one point only. Because the vertical line, because if I give you x, you must give me only one y. So if you want to have something similar for the inverse function, remember we switch x and the y. So the vertical line would be changing to the horizontal line. So this is going to be, a geometrical test, if you like. Again, depends what you want to do in future. If you want just to stay with the calculus, business for calculus for business, that would be fine for you, but not bad to know. Okay, geometry. You have a couple of problems in your book. You want to answer that problem, you need this one. So again, we recall that. If y equal to the f of x is a function, is a given function, then then each each vertical line each vertical line intersect, remember, intersect the graph of f, graph of f at most one point, at most, one point only, one point only. This is the one that we call it, this is the one we call it vertical line test. Vertical line test. Vertical line test. Now, in the case of the inverse function, in the case of the inverse function, of the inverse function, your inverse function is what? Inverse function of this is it. This is y equal to the f of x. Then you are going to have x equal to the f inverse of y. That vertical line would be changing to the horizontal line. In the case of the inverse function, in this case, each horizontal line would intersect, will intersect the graph of f, y equal to the f of x at most one point, at most, at one point, one point. So this is going to be a test for geometry, that a function would be given to its graph, and they ask you whether this function would have an inverse. As I told you, your functions are very limited in this course. But if you want to do something in future with others type of function, this test would be important. Okay, so this is going to be the type of question that you have in your book. A graph of the function is given to you. They ask you if this function would have an inverse. So you have to apply the horizontal line test rather than the vertical line test. Okay, so determine if the function okay f with the given graph okay has an inverse function okay, you just apply the horizontal line test. Look at this one. This is the function. This is the one that we did, y equal to the x squared. But we want to use geometry. If you want to use geometry, you just take the horizontal line test. You see horizontal line would intersect the graph at 2 points. This is what I was talking about. So I told you that you give me the y, I give you 2. Okay, I give you y, you give me 2x. You see, this is going to be horizontal line. It intersects the graph at 2 points. So this is going to be 1 point, this is going to be x1, and this is going to be x2 if you like. So since the horizontal line intersects the graph at more than 1 point, so the function has no inverse. The function has no inverse. So we are not going to try. Because you cannot solve, you see, it's y equal to the x squared. You cannot find the x. But if you restrict it, look at this one. Look at this one. Is y equal to the x squared, but you just consider the x to be positive. Okay, if you like, this is y equal to the x squared with the domain of negative infinity and positive infinity. But this is y equal to the x squared with the domain of positive numbers only. It has a nice inverse, you see. If you take any horizontal line, that would intersect the graph at 1 point only. So the function has an inverse. The function, okay, has an inverse. So it's a kind of, we call it geometrical test, if you like, to check to see if the function would have an inverse. Okay, it's easy to operate. Okay, and it's very similar to the vertical line test that we did. Okay, so this is going to be one version that we can do it using geometry. Okay, a geometrical format. Any question? So we have some, we are not going to give on the test because we are not going to give, get the graph. But if you want to do it in your book, you have some problems. They ask you if the function would have an inverse. You just pick this horizontal line. If they intersect the graph at 1 point, then you do that. Okay, this is one remark. What is going to be the last remark that we're going to have? And this is it. I try to avoid composition function, but you have some problems in your book, then you have to do it. Okay, so what is going to be that remark? That's algebra. But the one that I want, I give you the function and I ask you to find the inverse. That's what we need. But what is going to be this remark? This remark is, you see, as I talk about it before. If you have a number 2, the inverse of the 2 is reciprocal. So 2 times 1/2 would be 1. So in the case of the functions, the operation that we're going to use is the composition of 2 functions. What does it mean? This means, you see, if you have these 2 functions, okay, if a function. Have some problem in your book, okay? The function f, okay, has an inverse function, let's say g, then the composition of these two functions, you see, f of g of x is equal to g of f of x and is equal to the x. It's exactly like the one that we did for the numbers. If you multiply a number by its reciprocal, you get 1. It's the same thing. Okay, x is like looking into the mirror. So in your book, two functions are given, and they ask you to check if these two functions are going to be inverse of each other. You can you may you may be asked to get this composition and confirm it. Okay, but for our purposes, we are going to ask you to find the inverse yourself for us. Okay, so let's give examples of your book. Okay, so two functions would be given. These are going to be just the three functions that I give you really. Example, it's good practice. Okay, so how are we going to do it? This is it. We want you to verify that f and g, verify that f and g are inverse function, are inverse functions. I give you two options. You can use either one. Okay, what is going to be this one? I did this one before, so I switched it into this is from your book. Okay, this is number, okay, they are all, we can pick two. Let's go with the 24 first. It's a number 24, okay, of this section, of the section 2.7. Okay, and what are the function? F of x is equal to the 3 minus 4x. Okay, and g of x is equal to 3 minus x, okay, over 4. So you want to confirm that one of them is the inverse of the other one. You have two options. The easiest one is find it. Find the inverse of the other one. Okay, so I give you two options. Solution. Let's do it. Get this function. F of x equal to 3 minus 4x. Find the inverse of this function. Okay, we already talked about it. How are we going to find it? Okay, so find the inverse. Remember, suppose two steps. Suppose y is equal to the 3 minus 4x and solve for x. That's easy way to do it. You know that we talk about it. How we're going to solve for x. Isolate the x. Okay, different way to do it is going to be y minus 3 equal to the negative 4x, or negative 4x equal to the y minus 3. Find the x, divide by negative 4. X equal to, okay, the coefficient is y, it's going to be 1 over negative 4 y, okay, minus, okay, minus 3 divided by negative 4. So it's going to be x equal to, we write this one as what? We write this one as a negative quarter of y. Negative would be positive, plus 3 quarter. Any question? So remember, this is your inverse function. Is f inverse of y. which is equal to, okay, you can, this is a negative quarter of y plus 3/4. If you want to change it to the x, change it to the x, switch. So that gives f inverse of x is equal to negative quarter of x plus 3/4, which is the same thing. 3 minus 4, you can rewrite it as 4 minus x plus 3, or f inverse of x is equal to 3 minus x over 4, and you're done. Okay, so I have the f of x, I find the g of x, the inverse of the function. Okay, the inverse of the function is 3 minus x over 4, and you are done. Okay, that's one easy method really to get this one. Any question? Suppose you don't like it. If you want to make things a little bit more complicated for yourself, check this one. You see? But this is easier method. I just do it for you so that you know that what's going on, okay? But this is much, much easier just to find the inverse. Okay, let me check that one just for once so that you see some people they don't like it. Okay, so that's the method, easy method. You just find the inverse. And of course, we just give you the function and we ask you for the inverse. But this is just for the sake of the book. Okay, so method 2. Let's see if you like it. Method 2. And you don't have to pick this method, of course. So it takes time, but it's not bad. I need the functions again. So the function was, okay, this is it. 3 minus 4x. And the other one is g of x is equal to 3 minus x over 4. So one way to do it, just get the composition function and show that they are the same. Okay, let's see if you like it. Let's find f of g of x. Remember, bring the g. What is the g? Negative 3x over 4. Drop it into the box. What is the f? 3 minus 4 times the box. So it's a 3 minus 4 times the box. What is in the box? 3 minus x over 4. Simplify it. These two would cancel out. That gives you 3 minus x. So this is going to be 3 minus 3 plus x. These two cancel out. We get the x. So f of g of x is x. It's like, if you multiply a number by its reciprocal, you get identity, you get 1. Okay, but you're not done. You have to check the other one. Okay, let's check it. See if you like it. How about the other one? G of f of x. Okay, what is g of f of x? Bring the f of x. What is that? 3 minus 4x. Okay, drop it into the box. What is the g function? G function. 3 minus a box is equal to 3 minus a box. What is in the box? 3 minus 4x divided by 4. Simplify it. The top, 3 minus 3 plus 4x over 4. Simplify. 4x over 4, which is x. So g of f of x is equal to x. That's it. So from two directions, you prove that the composition functions are the same. F of g of x is equal to the g of f of x and is equal to the x. So they are inverse of each other. Okay, so f and g are inverse function. Inverse functions. You see, that's That's the one. Algebraically, it's nice. Mathematically, it's very good, excellent. You see? But which method do you prefer? Okay, we leave it to you. The second one or the first one? You see, the first one is easier. Okay, the second one is good for proving something really, but the first one is much, much easier. And we are not going to give you the inverse, of course, on the test. Okay, we ask you to find the inverse. This is, it's just too easy. But it's nice, okay, nice to see that this formula is working, if you like. The composition of two functions give you the identity function, okay? So you have quite a lot in your book. They ask for verification. So there is no application of which method are going to use. So pick the one that you like, or the one that's going to be quick to do it. And they are going to be all around the three functions really, the one that I gave you. Okay, so when you do your assignment, you do the either one. Just find the inverse, confirm it, or composition function from those sites must be the same one. No obligation to do whatever. Okay, any question? There are three types. I'll give you another one. This is number 15. Three types only, and we give all of them in your next quiz, and that's what we need. 15. The functions are f of x equal to x cubed plus 5. You see, all of them, they repeat this one over and over and over. And the other one is g of x equal to cube root of x minus 5. That's it. You want to prove that one of them are the inverse of the other one. So you have to show two choices again, but I do only one. Composition function or the direct one. Okay, direct one is easier. Okay, there you are. Solution. Take one of them. F of x equal to x cubed plus 5. Remember, call it y. Suppose y is equal to the x cubed plus 5 and solve for x. Solve for x. How are we going to solve for x? This is it, subtract the 5. So that give y minus 5 equal to the x cubed, or x cubed is equal to the y minus 5. You want to find the x, take the cube root. Cube root of x cubed equal to cube root of y minus 5. Cube root of x cubed is x. Remember, it was a square, we'd be in trouble. We need the absolute value, but not for this one. X is equal to cube root of y minus 5. That's it. This is your inverse function. So f inverse of y is equal to cube root of y minus 5. You don't like the y, change it to the x. Switch to the x. So f inverse of x is equal to cube root of x minus 5, which is the same as the g. See? Cube root of x minus 5 is going to be the inverse function. Okay, so just find it rather than checking the composition function. Okay, composition function is nice. Okay, at least we give you one proof that this is going to be nice. Okay, so we can use FGX, FOG and the GOF to get these numbers or directly find it. Okay, any question? So I think this method is easier. That is a type 2. How about type 3? So I just repeat the 3 more examples for you. Then we fine. Okay, what is going to be, let's give you a number, okay, give you this number 72 if you like, or I give a number, that's 32 from your book. Okay, this is number 32, they're all the same. And if you want to give 5 problem from this section, just pick the one around these numbers. Okay, so you practice for your test really. Okay, there you are. This is going to be the type 3 that we talk about it. F of x equal to quotient x plus 3. Okay, x plus 3 over x minus 2. This is one function, and the other one is g of x. The g of x is 2x plus 3. Okay, 2x plus 3 over x minus 1. You pick one of them, it doesn't matter. Pick the first one or the second one. Okay, it doesn't matter. I picked the second one for you for this one so that you can see it. Okay, just for a change, I picked the other one for you to get the first one. Okay, are you ready? Solution. Pick one of them. Let's pick g of x. G of x is equal to what? G of x is equal to 2x plus 3 over x minus 1. You know that the domain is all real numbers except 1. So again, suppose you call it y. Y is equal to 2x plus 3 over x minus 1 and solve, okay, solve for x. You know that to solve for x, you have to cross multiply. So I rewrite it here, y equal to 2x plus 3 over x minus 1. Cross multiply, you call this one 1 cross y times x minus 1 equal to 1 times 2x plus 3, 2x plus 3. Keep going. We are going to distribute it. So that gives us the xy minus y equal to 2x plus 3. Okay. Then we want to solve for x, so put the x's together. So that gives xy minus 2x equal to, move the y to the other side, that gives y plus 3. Okay, all the x's to one side, everything goes to the other side. We cannot combine them together, but we can pull out the x as a factor. X out, so that gives y minus 2 equal to the y plus 3. Now we have to divide. We know that we divide, but we impose the condition. X is equal to y plus 3, y minus 2, put the condition, y not equal to 2. Okay, you have to put the condition, otherwise you can't find it. So this is your G inverse, if you like. This is the G inverse of y, which is equal to y plus 3 over y minus 2. Okay, you don't have the y, you don't like the y, change it to the x. So G inverse of x is going to be equal to x plus 3 over x minus 2, which is the function. You see, we get exactly the same one. So it doesn't matter. If you pick one of them, you can find the inverse, okay, of the function as the other one to get these numbers. Okay, so that would be easier, unless you like the composition function, and then you can use the other ones. So this is going to be what we have for the composition function. We don't need more about this type of function, really. That's why we are not going to give you anything else, and that would be enough for us to be able to take care of it. Okay, any question? That's it, we are done with chapter 2. Okay, we did all sorts of property of the function in chapter 2. Then chapter 3 will be focusing on one group of the functions, which are going to be polynomials. Quite interesting chapter. So we are out of those definition and the property of the function, really. Now we are going to be focusing on some special functions. We start with the polynomials, then we go to the rational functions, and we end up with the exponential function and the log function for the end of the term. Okay, that's it. Any question? So check for your test over the weekend, for your quiz. We covered one more section before. Okay, before I checked the time. I think it's gonna be, yes. We get time to go one more section, the first section of the next chapter, It's quite interesting one. Sometimes I cover it in intermediate algebra, but we don't care. We are going to cover it again. It's a quadratic function, finding the vertex, symmetric, okay, axis of symmetry, graphing this type of function. We do it quickly, and we cover that section for your next quiz. Okay, and that's it. Any question? So have a good night, and see you next week.
Good
So,
night.
okay, bye bye. Have a good one. Take care.